Welcome to today's Energy Central webcast, Demand Response Management Systems, the evolution from point solution to enterprise platform. A few housekeeping notes we'd like to mention. For best results in viewing this presentation, we recommend using a wired high-speed internet connection, as wireless connections can be unpredictable. If you cannot get adequate sound from your computer speakers, you may dial into the audio portion using the telephone number listed in the right-hand panel of your interface under the audio section. Following the presentation, we'll have a brief question and answer period. You may submit your questions at any time using the interface on your screen. I'm happy now to introduce to you today's panel. We have with us today Brett Feldman, who's Principal Research Analyst for Energy at Navigant Research, Steve Gore, Director of Technology Architecture with Converge, and Pablo Bauleo, PhD and Energy Services Engineer for Fort Collins Utilities. Now I'm happy to hand the mouse and the mic over to our first speaker, Steve Gore. Steve, welcome to the event. You have the floor and should have control.
Thanks, PJ. And thanks everyone for joining us. Brett, myself, and Pablo are excited to discuss demand response management systems, the changing expectations, and the changing roles that they play within utilities. Brett will begin with an overview of the DRMs market. Then I'll discuss how the IntelliSource enterprise platform has progressed and where we are headed. And Pablo will present a case study with the evolution of the City of Fort Collins' demand response program. As PJ mentioned, we'll wrap up with a question and answer session. Brett, I'll turn it over to you to get us started.
All right, thanks a lot, Steve. I'm happy to be here. Navigant recently published a demand response management systems research report, so it's good timing being able to share some of that recent information here. Just give a quick overview and then let the experts get into the details. So you can go to the next slide, Steve. So I'm not here to endorse any particular vendor, let me say, but I thought this was a good kind of overview slide that I've seen from Converge, just to get people on the phone, kind of level set with what we're talking about, the demand response management system. Historically, demand response was somewhat of a manual process, using spreadsheets and making phone calls and a lot of one-way proprietary communication and control systems. But nowadays, the scale of programs has increased and their operational reliability is becoming more critical to the utilities. So the need for more centralized management and control, similar to what's done on the generation side of the market. So there's a lot of vendors that have come into from all different angles to create this demand response management category. So let me just kind of look from the top down at this graphic. So at the top you see a lot of the different utility systems and infrastructure. So you have things like metering and customer information systems and distribution management systems, all this operational information that feeds into the body of the demand response management system in the middle there. So the DRMs itself is responsible for all kinds of program management functions, from forecasting to device and installation tracking, program enrollment, data communication, obviously dispatch of demand response, measurement and verification, settlement. So it has to undertake all these different functions for the utility. And then in the bottom, you see the connection out to the end-use customers and devices. It can be through metering system, through cellular, Wi-Fi, all different types of protocols. And then you go to the end user, whether it's a residential customer or commercial industrial customer, thermostats, water heaters, all different types of devices that can be at the end of that line. So just want to give a basic overview. Then you can see on the left-hand side there's also a customer portal aspect as well to reach out to the customers with. So that's some quick background. So Steve, we can go to the next slide. And just want to go over a few of the major trends that we see happening in this space right now. And the first one is this idea of software as a service or cloud-based solutions. If you're familiar, that's a kind of a general technology term that you hear being used these days. You know, the iCloud and all those types of things. So basically, historically, utilities used on-premise types of hardware and software for all their operational systems. They still do for a large part, but there are opportunities to lower the cost and have quicker integrations and just be more efficient by using these cloud types of services. And I think things like DRMs are one area where utilities are starting to become a little more open to that, because it isn't necessarily as mission critical type of data, and the security is still very high, and sometimes security on private clouds and servers can be better than the utilities security system. So that's one barrier that has to be overcome, but we definitely see it as a trend that the industry is moving in. So next slide, Steve. Another one that we'll talk about, I know Steve is going to get into more detail on this, is the idea that demand response is not in its own box aside from other distributed energy resources. So DRMs is a distributed energy resource management system. Now, you might think of the demand response and separate from things like solar or storage or electric vehicles, but it's really the same type of system, just with different applications. So, you know, instead of a utility having to purchase multiple systems to manage these different resources, it is all really converging into one type of platform, so that whether it's a thermostat or a solar panel or whatever it might be, that that can be done through one central system. Next slide, Steve. And similarly, another area of convergence and more things being incorporated together is on the customer side. So aside from the distributed energy resources, you have things like energy efficiency programs, dynamic pricing programs, and more general customer engagement. So all those are being more tied closely together instead of being in silos like they were historically. And so again, if you can have one system, whether it's a DRMs or something that you can combine together to manage all those programs, or at least have them very closely incorporated, is a great value to the utilities. Next slide. Okay, so this is my last slide, just to look at what we see in the report that I mentioned as far as growth in the industry. And right now we say there's maybe 150 or so of these DRMs installations around the globe. The vast majority of them are in North America currently. And so another thing is that it's hard to really define a DRMs, because it's still a pretty wide-ranging category, from things focused just on residential or commercial to kind of full scale. And also you have different types of systems for large investor-owned utilities versus municipal utilities and electric cooperatives, and then also electric retail suppliers. Those are different categories, but we do see strong growth over the next several years in North America, and also we start to see it picking up in Europe and Asia as well. So I think there is a strong growth market for DRMs and DR in general over the next 10 years or so. So with that, I'm happy to pass it back over to Steve.
Great. Thank you, Brett, for that overview. I'm now going to talk about how demand response management systems in general, and Converge's IntelliSource enterprise systems specifically, have progressed to solve today's challenges and where we see these products headed in the future. Today's idea of a DRMS started with a load management system, or an LMS. These were pieces of software that were designed just to send signals to hardware load control devices. An LMS typically provided little to no forecasting, was specific to a single vendor or a single program, and required manual spreadsheets or maybe double entry into another system in order to handle the business processes around managing a demand response program. The initial demand response management systems came about by adding two key capabilities. The first of these capabilities was aggregating multiple types of programs and multiple classes of customers. So the DRMS is expected to manage direct load control, dynamic pricing, notification programs for residential, small business, agricultural, and large C&I customers. The second capability that enabled the DRMS was providing pre-built integrations and a single system of record for managing all of the processes associated with a DR program. So this would include move-out, move-in processes, meter swaps, customer enrollment, equipment inspections, event overrides, measurement and verification, and customer call center support. Examples include Pepco Holdings, who have used IntelliSource to successfully enroll over 380,000 customers and to manage more than 450,000 customer site visits. A second example, Gulf Power, is using IntelliSource to manage a pricing program with two-way devices controlling HVAC, water heaters, and pool pumps. Gulf was one of the first utilities to add a customer portal to a demand response management system, and they have seen customer satisfaction scores for their program above 95%. The next progression for the DRMS was harnessing the capabilities of real-time two-way devices. With these devices, the DRMS can provide an interactive customer portal that allows utilities to engage with their customers, encourage energy efficiency, and promote other utility programs. Additionally, by combining metering, weather, and the two-way device data, the DRMS can provide a much more accurate, granular, and responsive forecast of load that is available to be controlled. I'll let Pablo talk about how the City of Fort Collins is using IntelliSource Enterprise with their two-way devices. The progression to today's modern DRMS has been providing new operational uses of DR and new outcomes for utilities. Today's DRMS can make a $100 Wi-Fi thermostat have the same energy efficiency features as a $250 Wi-Fi thermostat. The DRMS can also provide frequent and automated fast DR for specific grid areas experiencing high congestion. The DRMS can also balance customer comfort during extended events lasting 8 hours or more. These outcomes are typically achieved by supplementing utility direct installed devices with new sources of load, including those offered by bring your own thermostat providers. As an example, Central Hudson is using the IntelliSource Enterprise software to execute a targeted demand management program that provides a lower cost alternative to traditional investments while increasing asset utilization in targeted areas over the next 7 to 10 years. The next progression, as Brett mentioned, is from a demand response management system to a distributed energy resource management system. What does this look like relative to the capabilities that we've already discussed? Well, we evolved from predicting DR load reduction to also predicting load shifting, predicting the potential to increase consumption, and predicting how customers might behave given different scenarios. And maybe more important than the specific forecasting models is the idea that the forecasting functionality evolves from a siloed solution to a platform that supports a set of applications providing analytic functionality for models and forecasts that we haven't even imagined yet. Program types supported by the DERMS will evolve from cycling a set of devices to orchestrating a complex mix of distributed assets. This will involve looking at the whole home as a set of processes that can be optimized in order to help achieve positive grid outcomes. And Pablo will talk about an example of that around refrigeration. From a workflow perspective, the DRMS is already a system of record for demand response assets in and around consumer meters on the distribution grid. It will be a natural extension to include new distributed energy assets in the evolving DRMS. Existing processes such as enrollment, customer support, and settlement will be extended to incorporate these new distributed energy resources. The capabilities that these DERs provide will also enable new integrations with outage, distribution planning, and advanced distribution management systems, enabling utilities to realize increased operational value from these assets. The DRMs will need to model and communicate with solar inverters, electrochemical batteries, electromechanical cogeneration, and thermal storage appliances. In addition to these large sources of load, the DRMs will also communicate with a wide variety of appliances that will be enabled through the Internet of Things ecosystem being built out by companies like Amazon, Google, and Apple. So why do all of this? Why proceed down this path? What problems will these new systems solve? Ultimately, the distributed energy resource management systems will enable utilities to unlock the value of the distributed bidirectional grid. DRMs will help utilities stay relevant with their customers, avoiding disintermediation from third-party energy entrants, and supporting new revenue streams. The DRMs will also play a critical role in tracking, forecasting, and optimizing DERs in order to provide reliable power systems with high levels of renewable penetration. The DRMs will also help utilities roll out new rates that could include dynamic pricing, pay-for-performance, and transactive energy components. These benefits evolve and supplement the current benefits of peak reduction, customer engagement, deferred T&D costs, and customer satisfaction that are being realized by DRMS users today. IntelliSource Enterprise has grown with our industry to become the solution that utilities use for the optimized command and control of demand response assets. And Converge is excited about the investments we are making today to incorporate DERs and to become the distributed energy resource management system of tomorrow. And with that, I will hand it over to Pablo to talk through the City of Fort Collins use case.
Thank you, Steve. Hello, everyone. Thank you also for taking time of your busy days to attend this webinar. So if you could move to the next one, before I go to the content, I just have to make a brief disclaimer. I'm going to be showing some details of our program that is done with a specific partner, Converge. But basically, the disclaimer is that City of Fort Collins does not give preferred status to any of the many vendors that we have working with us. So if you could go to the next one, please. Thank you. So I thought I could cover a bit about City of Fort Collins. We are in Colorado, about 70 miles north of Denver. The population is 160,000, and we are the hometown of Colorado State University. 20% of the population of town are actually students, college students. We have a significant beer industry in town. Maybe that explains why 1 out of 5 people in town is a college student. I wonder about that. We also have high-tech companies in town. And then specifically on Fort Collins utilities, we are a municipal utility. We are a multi-commodity utility. We provide electric, water, wastewater, and stormwater services. On the electric side, we are a distribution-only utility with about 70,000 electric customers and 62,000 of them being residential, and we are fully AMI deployed. Next one, please. So about 2.5 years ago, we rolled out the Peak Partners program. We used to have a previous one-way system in place, and it was time to get into the 21st century and go into two-way devices. The reason why we have the program is just because we have financial savings. We have a coincident peak rate with our generation entity. We are not constrained in generation or in the distribution system. So again, it's just a financial incentive that we get. And the main three prongs that we have in the program are Wi-Fi thermostats, just during the summer months. We also have electric water heaters with a switch, that is a cellular switch, two-way device. And we are about to go live with an open ADR headend for the commercial and industrial sector. We also have a small home energy monitor program that is with in-home displays. It seems to be that for some customers, in-home display is something that they want to have for a long period of time. But for most people, actually, after a few weeks, you learn all that you were going to learn from these devices, and then they end up on a kitchen drawer. So what we did here is we have a partnership with the library that people can go and check them out for free, have them home for 3 weeks, use them, and then return them, so then they are available for the next person that wants to check them out. Next, please. So we do have the IntelliSource platform, and it's really a common platform across all these different roles and actors. I have like all our CSRs on the call center that take care of enrollment of customers and support of customers, and they might take a call and make some notes, and all that goes into the DRMs, and that information then becomes available to the central office that might push that into the field services, or it might come to me as one of the program managers. The operation rooms also has access to the DRMs, and they connect with the devices. That way, all that information is shared across all the platform. Of course, we have role-based access to the system. Not everyone gets access to everything, but it's a really nice common platform. And also, our customers are interfacing with the DRMs. They don't really know it. They only see the thermostat portal on their phone or the computers. But again, all this information is across a common platform. So I mentioned we used to have a one-way system, and as Steve said before, there were a lot of independent databases and spreadsheets, and it used to be much more cumbersome in the past. All those processes are much more streamlined at this point. Next one, please. So as part of the streamlining of processes, this is actually the dispatch screen. It's a screenshot of the system. And you can see in the center of the screen, we have different subgroup of resources. And with just a few clicks, our operators can choose to dispatch residential water heaters, or the OpenADR commercial resource, or thermostat, whatever we needed, given the needs at the time. With, as I say, with just a few clicks, is very straightforward to do something that used to be much more of a complex task in the past. And because this is a cloud-based solution, all this is available anytime, anywhere. We have 4 people, my organization, that have dispatch rights on the system. And in 2 opportunities, actually, I know that dispatch happened through smartphones. It was that our operators were on the move or were at a meeting and the need came up. They were able just to pull up their smartphones, enter the event, and keep going at the meeting or doing the other activities they needed to do. Next one. And then some of the really nice things and kind of like cutting edge, at least for us, things that we are doing is that we are having optimized dispatch. This is a screenshot of our forecasted load, so we can have a good idea of when a peak is going to happen. On the bottom, you can see is a forecast 7 days out, and then on the center of the screen, you can see an hour-by-hour forecast. And there are 3 numbers on each one of the columns. The number in the middle is the forecasted hourly DR capacity. We can do that because we have telemetries coming back from all the devices in the field. We can do that because we have AMI data, true interval data, for each one of the participating customers. And one of the things that we're doing now is, before, all these were a lot of independent activities, even between us, the distribution utility, and the generation entity. The most we could do was maybe give them a call. Hey, we're going to have an event later today. Now, the platform automatically notifies our generation entity whenever we're going to call an event. The generation entity has access to this screen that you're seeing right now, and they can see what load reduction to expect. So then they can fine-tune the generation of their resources, of the resource generation, expecting the upcoming event. Next one, please. So when I was invited to this webinar, I was asked, to talk a little bit on what is that me as a utility guy sees happening in the industry and where I think the industry is going to go and how it's going to move forward. So I think that right now there are like 2 different fields that are not really talking with each other that much. One of them is the utilities that are pushing time-varying electric rates like time of use or CTP and all these things. And then there is all the consumer electronics industry that provide thermostats or electric water heaters, washer and dryers, you name it. Basically, all those home appliances now are Wi-Fi enabled. So what I think is going to happen is that people are becoming really used to have Wi-Fi everywhere, and they're going to start automating the home. So if you could go to the next one, to respond to all these time-varying electric rates. And there are a lot of automation platforms out there. Most of them are actually pretty user-friendly and really plug and play. But it's a little bit like the Wild West, really. There are many. Some of them are stronger in one area than in other. And from the utility point of view, all these platforms, what they lack is a way to provide a coordinated action among homes in a defined geographical area. It's really good for the homeowner to automate things, but it does not allow yet the utility to coordinate all those activities. So on the next slide, please. I think that the main thing that needs to happen in the near term for the DRMs is to both leverage and deal with the large variety of existing platforms. It has to be a plug and play, kind of like the Lego blocks that you see there. Everything has to really fit and work. We need to leverage the fact that Wi-Fi is everywhere. And at the same time, we just need to put up with some of the challenges that Wi-Fi presents. One of the things that I have experienced is we are not an ISP in our time. We don't provide broadband. And there are two main companies that do that in Fort Collins. Some months ago, one of them started to upgrade all their customers' routers. And that meant that pretty much in a couple of months, I lost a few hundred thermostats because a technician will show up, will replace the router, customers will connect their phones and maybe their iPad or smart TVs immediately, but they will forget about connecting whatever thermostat they have home. It took months to recover all those thermostats. In many cases, we have to do outbound calls. So Wi-Fi is really nice, but it also presents some challenges unless you actually can manage the Wi-Fi resource. Next slide, please. So then I started to think, what is that needs to happen probably in the mid-term, and that it will be really nice from the utility point of view, that is to be able to dispatch the energy use. Historically, DRMs have been used just to decrease energy use. On a DRMs, I would like to see that we can also increase the energy use. That is just because, I think everyone in the audience is familiar with the duck curve issues, overgeneration. It's something that we need to prepare for that. And I think that, the obvious places to start with will be with electric vehicles, perhaps with, some thermal storage with grid integrated electric water heaters, and then with some sort of magic storage. I don't know what that storage form will look like, but we certainly need to have a storage system, widespread adoption of it, because I've heard this at a webinar years ago, and I think it's really true. The energy industry is like being in an ice cream business without a refrigerated warehouse. There is generation, either central generation or distributed generation, and we are constantly trying to follow that. We need a storage so that way we can manage whenever we have overgeneration in the system. And on the next slide, I'm going to talk a little bit as to what I think is going to happen, or where I would like to see this going. We're here at Fort Collins are planning is we need to get under the hood of the household processes. A particular process that I think is waiting to happen is to be able to work with the refrigerator defrost cycle. Typically there are 500 watts. I actually measured the refrigerator on my home. It peaked at 750 on my particular refrigerator. And defrost cycle happened, several times a week, in some cases a few times a day. And every home has a refrigerator. Most homes have actually two refrigerators because of the freezer in the garage. So then just try to picture that we could have all these load that we could either delay, perhaps that wouldn't be that much load, but just try to picture to be able to call thousands of refrigerators at the same time with the defrost cycle. Of course, this is not easy, and that's where I think that we need, to start really working with the consumer electronics companies, so that way, as refrigerator gets sold and replaced on the homes, they are enabled to connect with some sort of command and control system, and then, to be able to do these kind of things, to dispatch the defrost cycle, and as important, to be able to provide information to the utility, like, I just did my defrost cycle 2 hours ago, so don't call a defrost cycle on this particular device. We need to know what is the availability of all these household processes. And even going further, I'm thinking that we should be able then, to dispatch individual electric circuits, the ones that are for the laundry, the cooking, electric vehicles, whatever, using stored energy. I kind of like think this is probably 10 years at the least in the future, but more distributed storage and people being able just, to, in a completely automated and transparent way to them, be able to switch loads, between the grid and their storage. So on the next slide is like, what is that we get out of this, when we get all these different parts, all these plug and play, the Legos again, all these different platforms for automation, all the thermostat, the storage, all of these talking and working together. Well, at that point, as the utility guy is like, we get an improved grid load factor. That is automated savings for generation, transmission, and distribution. But another thing that we will get that is very important, is a big goal for Fort Collins utilities, is that this becomes a great tool for carbon footprint management. We will be able then to get a lot of renewable resource energy to be stored and to become available whenever our customers need to use that energy. So with that, I pass it back to Steve.
Great. Thank you very much, Pablo. So we have some time now to take questions and answers. Well, we'll answer them. We've gotten some great questions in the chat component of the webinar. Please continue sending in questions and we will try to address them. I'm going to start with a question that I think all of us can provide some input into. And the question is, what is your definition of a successful DRMS implementation? Why don't we start with Brett and get your thoughts on this and then go around to Pablo and myself. Brett?
Thanks, Steve. I can just give some generic answers, and I'm sure you guys can provide some more specifics, but just things like making sure it's delivered on time and on budget. Certainly can't take those things for granted. I've heard about things dragging on for a while and cost creep and scope creep kind of getting in there as well. And then another thing that we talked about is integration. So the system doesn't just sit on its own. It has to be integrated with a lot of other utility systems. So that's a huge part of the process, again, that doesn't always necessarily go smoothly. And then, finally, just the ease of use for the utility users once it's in place, because you don't want to have it be too complex, and the more intuitive it is for the user, the better. So there's just a few things that come to mind for me.
Great. Thanks, Brett. Pablo, what are your thoughts on a successful DRMS implementation?
Well, I'm going to say something that might sound obvious. A successful DRMS is the one that does what you need. And really, beyond just the silly thing I just said, is as, again, with my utility hat on, is I need to know what the needs of my utility and my market are, and then make sure that the platform we choose support those needs. And one thing that also I guess, at least in my mind, I've been always thinking is that a DRMS has to be a two-way communication system. That's just my personal definition. If you're using a one-way communication system, I don't think of that as a DRMS. So I will say that it has to be two-way, near real-time information, and by near real-time I mean minutes latency at the most.
Great, thanks, Pablo. I'll add my 2 cents to this as well, which is I think a successful DRMS implementation solves a problem of today. As Brett says, does it on time. As Pablo says, does what needs to be done. But also provides the flexibility to solve problems in the future. So provides the ability to expand beyond just that silo of DRMs or what we're working on today, to be able to provide capabilities for the next 3, 5, 10 years and do some of these interesting, neat ideas that Pablo presented in the last couple of slides there. Let me go to the next question that we had come in. This is for you, Pablo. How often do you call on the DR assets?
So that, as I said on my slides, we're doing this for financial benefit. So in each month that is a billing cycle for us with our generation entity, we have a demand charge. So we are pretty much calling the resources a few times a month. And again, we do that winter and summer and on the shoulder months, during summer with the HVAC, during the rest of the year with electric water heaters. And we do it on a monthly basis because of the billing cycle with our generation entity allow us actually to get savings each month.
Great. Thank you, Pablo. A question for Brett. How do prosumers, as opposed to consumers, interact with these evolving systems and programs? And Brett, maybe you could start with your thoughts around a definition of prosumer.
Sure. Yeah, it's a term that's come up a lot recently. I guess the simplest thing is that you're providing energy back to the grid some way, so that could either be actual generation from solar, or if you're storing in a battery, or I'd say that demand response can be considered a prosumer also, because you are still providing a resource back to the grid. And this is where I mentioned that there's no necessarily precise definition of a DRMS. You have some that are more on the end user side, like on the residential side. I wouldn't say there's a lot out there for customers directly at this point. That's a little ways off, and you hear about things like transactive energy in the future. But for more of the commercial industrial side, there are the companies like Enernoc or C-Power, those types of aggregators that have, you might consider a DRMS, but it is basically a portal for their end-use customers to participate and sometimes bid directly into markets. So I think you might call that a different type of a system, whether it's an energy information system or something like that. So I think on the C&I side that does exist, but for residential, still a little ways off until the individual end-use customers can really do that type of bidding.
Great. Thanks, Brett. Another question has come up about the underlying technologies that are driving some of this progression. And I'd like to talk a little bit about that. Certainly, what we've seen in this industry is a proliferation of data, right? So we have two-way thermostats, two-way switches. We have very granular, precise weather information. We have AMI data coming back. And one of the huge drivers in this space has been coming up with tools and processes to analyze that data, right? The catchy word is the big data analytics. But that is a key component to the work that Converge is doing, to the work that we're doing with the City of Fort Collins and with other customers to be able to provide better forecasts and be able to provide more optimized dispatch. So we're really combining the ability to process large amounts of data at a very high frequency and large scale with machine learning algorithms which are able to detect patterns and provide a high degree of accuracy in modeling these types of systems. Another question that's come in, discuss some examples of a utility's C&I and residential DR resources managed by a single enterprise system. Pablo, can you answer that one, please?
Sure. In our case, we have some thermostats, the Wi-Fi thermostat we've been talking about. We have those on residential and small commercial applications. It's basically the same equipment that just works for both. We also have electric water heaters, and we also use those on residential and small commercial settings. And for the C&I, what we decided to do is to have an open ADR head end, because that way we can use an open standard and support multiple building automation systems. And with most of our C&I customers, we look at cooling loads during the summer months. That's a very typical application. In some other cases, we might also work with process, like a manufacturing line or things like that. What is that it can be interrupted. And because now with the new system, we can provide advance notice, typically at least an hour and often 2 hours. The production floor management, can decide, oh, okay, we can shift this activity to later on the day or things like that. So that's kind of like a big picture of what we are doing with just basically one interface. We just click on what we want to do, and IntelliSource then dispatch all those commands.
Thanks, Pablo. Two similar questions, and I think it would be interesting to get both Pablo, yours, and Brett's thoughts on this. So the first question is, what is the deciding factor for utility when purchasing a specific DRMS? And then I think a related question is, at what point does a utility consider buying a DRMS? Brett, you want to start out on that question, please?
Sure, I can try to take both of those. So the first one, as far as deciding factor, from what my talking with utilities, it's not always about price or cost, it's about value. I mean, that's certainly a big consideration. There can be a range, but you want to look at the value that you're getting from it. So I think some of the things you've heard before about the definition of a successful implementation, things like flexibility and scalability and ease of integration, those are very important considerations. Security, so I don't know that I can point to one, but I guess one thing I'd say is it's not always just about the cost. There's a lot of other operational items that come into play. And the second one is about when would a utility consider it. That's a good question. I mean, you have some utilities that have had legacy programs for a while that are looking to upgrade their systems, like Pablo said, going from a one-way system to a two-way system can be more of an evolution. But then you have utilities that don't have any programs, and maybe they're starting them out. And in some cases, if you're starting a small pilot, you might not need a DRMS, but at the same time, if you know you're going to scale up fairly quickly, then it can be good to have some system from the beginning, so you don't have to change your process in the middle, and again, just have something that can scale up pretty quickly.
Hey, thanks, Brett. Pablo, your thoughts on when a utility should consider buying a DRMS or maybe a DERMS, and the deciding factors there.
So as to the when, what I will say is it really depends, again, a lot on the conditions of your utility, like why you want to do it, rather than when is why, I will say. Are you trying to save money? Are you trying to do better grid management? Are you trying, to do some carbon footprint management? So I will go with the why and then decide if the when based on, okay, I have a reason, can I do it? Do I have the resources to do it? And as to how to choose one, I completely agree with what Brett said, certainly was in our case. We were looking for the value of the system. Cost certainly was and still is a big part of this, but it's not just, the dollar sign associated with this, is what is that we can do with this system. And one thing that is really important, I mentioned this, and I want to say that, it wasn't really an evolution from one way to two way for us. It was more of a need because of our very aggressive climate action goals. We know at Fort Collins Utilities we need to get better as to how to use our electric grid. So having the DRMs is a tool that we're going to be using for better grid management.
Great. Thank you, Pablo. We're just going to do a few more questions here. I'm going to take this one. Question is, how does a DRMS take into account the ISO rules and operating guidelines? So I think this is a great question. Many of the customers of IntelliSource Enterprise are within ISOs or have other regulatory mandates and rules around how and when programs can be called. So I think a DRMS needs to model those rules and restrictions around what's the lead time, how many times events can be called in a day or a week or a year, how often customers can participate in those events. And then I think in addition to modeling that, those considerations need to be taken into account when developing an entire solution. So we have a customer of IntelliSource Enterprise that has generally a 10-minute dispatch window. But when it gets through their processes, the amount of time for the technology solution to actually dispatch the devices, based again on this 10 minutes from their regulatory body, is about 120 seconds. So that consideration was taken into account as we developed this system, and Converge has written a white paper on how we were able to meet those restrictions with a large number. Today it's 100,000. Hopefully in the future it'll be up to 500,000 devices within that time frame. And I would add to that that as we move into the DRMs space, modeling the attributes of the devices themselves, right, the water heaters or the inverters or the batteries, and also the programs around that, whether it's a pay-for-performance rate, dynamic pricing rate, again, ensuring that there's fair participation for customers will be a key element of a distributed energy resource management system. Let me close with one last question, and Pablo, I'd love to get your thoughts on it, and then I will maybe provide some of mine as well. Question is, how do you view the threat of improvement in battery technologies to the DRMS? Pablo, what are your thoughts?
I'm not sure if I got the question. It's like a threat. I'm not sure if I really understand it. Can you reformulate it?
Okay, well let's reformulate it that way. Is the development and uptake of battery technology, and let's say ones that would be behind the meter, so not utility scale batteries, but residential or small commercial batteries. Is that a threat to a DR program or a DRMS? Or is it an opportunity?
Thank you. I don't really think that behind the meter storage is a threat to a DR program. I think is a really great opportunity. I believe, and notice that now I'm talking of the program rather than the DRMS. I believe that the key point is to set up a program in such a way that if someone wants to get, some storage on their home, either the electric rate is such that encourage the end user to use storage at a time that is also beneficial for the utility, or that you have some way to incentivize the use of storage with some contract with the customer that will also let the utility use the storage capability.
Great. Thanks, Pablo. And I would agree. I think from our perspective, we see battery technology specifically, but generally storage and maybe distributed generation as an opportunity. I think Pablo is completely correct that the programs need to be designed correctly. And then that's really where we see the next phase of our software and other DRMS softwares going, is to be able to provide the capabilities for utilities to manage those programs and see value from them, and also for consumers themselves, or prosumers perhaps, to be able to interact with their utility and recognize even greater value from the assets that they have purchased. And we think that that's the direction that a distributed energy resource management system will take us over the next few years. So with that, I would like to thank our panelists, Brett Feldman and Pablo Baleo. I'd like to thank everyone for attending and the awesome questions that we got. And I would like to hand it over to PJ to close us out.
Thanks, Steve. And thanks again. Great presentation. For our audience, we hope you've enjoyed today's discussion. As you log off, please take a moment to complete our survey and give us your feedback so we can continue to provide you with quality content. Thank you for attending, and this does conclude today's presentation.